So this is CPM Precalculus Chapter 2, Number 2. So let us look at an application of a piecewise function. Okay, Lisa, she makes $4 an hour babysitting before midnight. So that's before midnight, she gets $4 an hour, and $6 an hour after midnight. Okay, so there's two different pays for the different times of the day. Okay, she begins her job at 7 p.m. Complete the table below for the total amount of money Lisa makes. Okay, so here's what we're given. The time row is 8, 9, 10, 11, 30, 12, 12, 30, 1, 2. Okay, that's just the time. We know starts at 7 and she's getting off at 2. So hours babysitting, we're given at 9 o'clock she's worked 2 hours, at 10 o'clock already 3 hours, okay, and a few other times. Money earned, well, from 7, she starts at 7. Let me write that. Starts at 7 p.m., right? So the first hour she gets $4. So how many hours has she babysat? 1. Okay, that's pretty straightforward. So at 9 o'clock she has worked 2 hours. Well, how much money did she get in 2 hours? Well, it's just 4 times 2 is 8, right? At 10 p.m. she's worked 3 hours, so she gets an additional $4, so that's $12 she's earned so far. At 11:30, be careful, we're skipping from 10 to 11:30, so that's another hour and a half. So that means she's been working 4.5 hours, right? From 7 till 11:30, because we know we were going from 10 to 11:30 is an hour and a half, so now she's worked 4.5 hours. And that means she gets an additional $4 for $4, so that's going to be 12 plus 4 for the 1 hour plus 2 for the half an hour, so that's going to be $18 here. Okay. At midnight, she's worked 5 hours. Well, that means she just gets 5 times $4, so now she has $20, right? 12:30. Now, here's where the pay scale changes right at this line, right? Because now she's getting, instead of $4 an hour, she's getting $6 an hour. So how many hours has she worked? Well, she's already worked now 5.5 hours because the jump here is just 0.5 hours, right? But how much is her pay? Well, in that 30 minutes she worked, she gets, well, what is half of 6? She gets $3. So this is going to be add 3 to 20 is $23 once the clock hits 12:30 a.m. 1 a.m. she's been working 6 hours. Okay, they give that to us. Makes sense. And she gets another $3 from the difference over here, so that's $26. And 2 a.m. she gets another hour of work in, and she gets another $6 since it's after midnight, so that's going to be 26 plus 6 is $32. Okay, so there we go. There's the table filled in. Part B. If we want to fill out the entries after midnight in the table above, we need to realize the function is piecewise. Okay, that is, Lisa is paid at 2 different rates. One for the time she babysits before midnight. Okay, so one rate here to the left, right? And then one for the time she babysits after midnight. So that's starting here and to the right. Okay? So there's 2 pay scales. Since the rate changes at t is equal to 5. Okay, so they're saying hours babysitting, this is variable t, right? It starts at 5, right, is where the time changes and also the rate, right, from $4 to $6 an hour. We need 2 different rules. One for t is less than 5. Okay, so this over here is t is less than 5 hours. And one for, actually they say t is less than or equal to 5 hours. Okay, and one for t is greater than 5 hours. So here t is greater than 5. Okay? Find 2 different functions that would define how much money Lisa makes with respect to the number of hours she babysits. Express this function as a piecewise function using the notations shown in the previous problem. Okay? Use the notation shown below to get started. Alright, so what they give us in part B is f of t. So a function with the input of time is equal to something, they just have dot dot dot, for 0 is less than or equal to t is less than or equal to 5. Okay, so that corresponds to this region, right? You can even put the 0 is less than t is less than 5 here, right? So f of t is defined to be that and something else for t is greater than 5. Okay, and again, this is talking about this section over here. So what is the function? Well, first, we kind of have to think about, well, as the time goes up, right, she's just getting paid a constant $4 an hour. So that means we can graph this, right? If we graph this, if this is our x-axis and our y-axis, and we're saying x is the hour she babysat, well, at 0 hours, she gets $0. At 1 hour, she gets $4, right? At 2 hours, she gets $8, right? And it continues. 3, she gets 12. 4, she gets 16, right? And we keep going up till 5, she gets $20. Right, so it's here, here, and here. Okay, so if you graph this carefully, you're going to see that this is just a line. Okay? Alright, I know it's kind of messy here. Let me erase this because we're going to continue. So that's going up, right? And that's $20 right here. Alright, and that's the first 5 hours. So how do we find the equation of the line? Because we want to put this line right here. We want the line in green to be right here for t is between 0 and 5. Okay? So how to find the equation for a line? Well, just remember, we're given many points. We have 1 point here, 1 point here, 1 point here, 1 point here, 1 point here. So how many points do we need to create a line? We need 2 points. So let's go ahead and use 2 points. I'm going to use 1, 4, right, and 2, 8, right, and this is just my t value and my f of t value, right? T value is time, f of t is money earned. So I could use these 2 points to get the equation of a line using our y minus y1 equals to m times x minus x1. That's just our points low form, right? So first I also need to know m is equal to the change in y over the change in x, right? I could call this x1, y1, and x2, y2, right? Doesn't matter which 2 points you chose, you're going to get the same answer. So y2 minus y1 is 8 minus 4 over x2 minus x1 is 2 minus 1, and that gives me 4 over 1, or 4. Okay, so I get a slope of 4, and let me just plug in values. Y minus y1, y minus 4 is equal to m times x minus x1, which is 1. Okay, let me just simplify this, and I'm going to distribute the 4. So that's 4x minus 4, y minus 4 on the left still, and then add 4 to both sides, and I get y is equal to 4x. Okay, so this is the equation, and remember, I used x and y here, but what I really want to do is use, instead of x, let me write it in a different color. I want to use t, and instead of y, I want to be f of t, right? Because this is what I have the output as here. So what that will do is that's just going to change it to be f of t is equal to 4t, okay? Instead of y, I have f of t. Instead of x, I have t. So let me go ahead and write this down here. F of t is equal to 4t. 0 is between t is between 5. 0 is less than or equal to t is less than or equal to 5. Okay? So that's how I figured out the first piece of the puzzle, or the function. So how do we do the second piece? Okay, Well, the second piece is t is greater than 5. Again, we see the rate, right? Well, the rate, remember, before 12 a.m., the rate was $4 an hour, right? Well, that was also the slope, right? Because that was the change of our output over time, right? That was just $4 an hour. Well, that is the change in the money, right? The change in the money over the change in time. Okay, so it's change in y over change in x. So this is going to make me believe that after 12 a.m., our rate is $6 an hour, so our slope is probably going to be $6 too. Okay, so let's figure that out. Let's use any 2 points. I'm going to use these 2 points. You can use any of these 3. So I'm going to say x1, y1 is going to be 6, 26. And x2, y2 is going to be 7, 32. Okay, so I'm just picking these 2 points to get the equation of the line. And if I wanted to graph this, it would look something like this over here. But I kind of ran out of space, so you can go ahead and graph that using these 3 points, and you'll see. Okay, so but anyway, let's go ahead and get the equation of the line given these 2 points. So I know y minus y1 is equal to equal to m times x minus x1. And that's my point slope form. Slope is just change in y over change in x, which is y2 minus y1 over x2 minus x1. Right? Here's my y2 is 32. My y1 is over here is 26. My x2 is 7. My x1 is 6. Oops, let me just fix this. Minus 6. Okay, so 32 minus 26 is 6. Over 7 minus 6 is 1. And I get 6 as my slope. Just as I kind of guessed, right? But do not go here and just write, well, then my answer is 6t. Because we need to go ahead and use the formula to get the equation of the line. Because in fact, it is not 6t. So let's go ahead and plug it into our point slope form. Now y minus y1 here is 26, equals the slope m, which is 6, times x minus x1. X minus x1 here is 6. Okay? So let's go ahead and distribute the 6 across. We get 6x minus 36. And on the left we have y minus 26. Okay. Solving for y, I add 26 to both sides. So I get y on the left is equal to 6x, combined like terms, minus 10. Okay? And again, we used, instead of y, we have f of t. Instead of x, we're using the variable t. So this is the same as f of t is equal to 6t minus 10. Okay? Remember, this is just our variables because on our x-axis, we have t, right? We don't use x. In our y-axis, we're using f of t instead of y. Okay? So let's go ahead and put our answer in here. F of t is now 6t minus 10 for t is greater than 5. All right. So that is defining the piecewise function f of t. And we got both pieces defined. All right. And so that ends CPM Precalculus Chapter 2, Number 2.